All right, so let's continue with our solving. Don't forget, we are still solving COOU workbook. COOU workbook. So question number 14. Question number 14 says, okay, that we should find implementation that if X is an element of set A, then X is an element of set B implies that in fact it can imply that A intersection B is not an empty set. Okay, they have something in common, so it's not an empty set. Okay, that is for 14i. 14ii 14ii said that if X is an element of set C, they say then either X is an element of set A or X is an element of set B implies that what? In fact, it can mean that either A is a subset of C or B is a subset of C. Okay, and their intersection is not empty. That A intersection B intersection C is not empty. It can mean that. So they say that if X is an element of set D and X is not an element of set A, implies that do I say that the intersection is empty? But I'm not really sure. Well, let me just say that the intersection is empty. But you can verify yourself. So let us continue from number 15. Number 15 says use the description of A, B, C, and D, okay, to fill the following. And they say that A is what? Even numbers. B is odd numbers. C, whole numbers. D, prime numbers. Prime numbers greater than 2. E, normal prime numbers. So they say we should use this thing to answer the following question. That's for number 15. 15i. 15i says okay, that 49 is an element of whole numbers. It's an element of set C. Okay, so they said the question said use the description of the set in question number 13, and these are question number the description of the set as A, B, C, and D to translate the statement below into the language of set. They now say 49 is a whole number. The question say 49 is a whole number. So how do you translate it? You say that 49 is an element, whole number is set C, is an element of set C. That is how you translate it. Okay, 15ii. 15ii said half is not an even number. Okay, it means that half is not an element of even numbers is set A. It's not an element of set A. So let us continue. I. 15 I. 15I said that x is not a prime number greater than 2. So it means that what? That x is not an element of prime numbers greater than 2 is d, so it's not an element of d. 15IV said 2 is a prime number. So it means that what? 2 is an element of, which one is a prime number? E. So 2 is an element of E. 15V. 10 is not an odd number. 10 is not an odd number. So it means that what? 10 is not an element of odd number is B, so 10 is not an element of B. That is for question number 15. Let's move to 16. Question number 16. 16 says, write down the following statement in words and state whether they are true or false. I said, if x is equal to a and a is a subset of b, then x is equal to b. Okay? Okay, they say that, look at the statement. Let me look at how they wrote it, but look at how to read it. Look at how to write the statement. If x is equal to a, you write it in words, and a is a subset. This thing is long, not CO. This is subset. A is a subset of b, then x is equal to b. Then x is equal to b. We say that x is equal to a. I will not say that A is a subset of B. Can we say that x is equal to B? It's not true. It's not true. Since A is a subset of B, A cannot be equal to B. Okay? You know, the meaning of this thing is that since they say that x is equal to A, if you say that x is equal to B again, it means that the same x is equal to B. X is equal to A and is equal to B, which means A is equal to B. And if A is a subset of B, okay, A cannot be equal to B. So it's not true for I. 16II. 16II said, if x is not an element of A and B is equal to A, and B is equal to A, 16II, B is equal to A, they say then x is an element of B. Okay, let me read it again, the way you write the statement. If x is not an element of, you write it not an element of A, and B is equal to A, then x is an element of B. It's not true. If B is equal to A, and x is not an element of A, automatically x cannot be an element of B. So you write that it is not true after writing the statement. So 16II. 16II said, if A is a subset of B and B is a subset of C, then C is a subset of A. Okay, look at how you write the statement. A is a subset of B and A is a subset of B and B is a subset of C, then C is a subset of A. Is that correct? Which means, look at this, let's know how, let's interpret it. They say that A is gotten from B, which means B is bigger than A. And they say that B is gotten from C, which means C is bigger than what? B. Is it correct for you to say that C is now smaller than A? It's not possible. It's not possible. So it is false. It's not true. It's false. Okay? So 16IV. 16 IV. They said that if an empty set prime is a subset of A and C is equal to the universal set, they say then C is a subset of A where you represent the universal set. So how do you write the statement? They say if empty set complement, the complement of an empty set is a subset of A. Okay, you know that the complement of an empty set is a universal set. Yes, please note that the complement of a subset is a universal set, and they say that C is equal to this. Can we say that C is a subset of A? It is not possible. It's not true. Okay, if C is equal to the universal set, okay, and the complement of this is a subset of this, yes, it's true. It's true because empty set complement means means what? Means the universal set, and C is the universal set, and which means the universal set is a subset of A. So it is correct. It is true. So this is true. Let's move to question number 17. Question number 17 said that if A, they say use the defined set in 13. We are still using the one in 13 above to answer the following question. Let's still list it again. The set in 13 say that A is equal to even numbers, B is equal to odd numbers, C is equal to whole numbers, D is equal to prime numbers that are greater than 2. E is equal to just prime numbers. Okay, so shoot. So what do we do? So permit me to refill. Okay. So question number 17 now said that if A is a subset of B prime, comma, then A and B are disjoint sets. Okay. They said I don't know if they want us to answer if it is true or false, but let us just check. If A is a subset of B prime, then A and B are disjoint sets. Even without this statement, A being a subset of B prime. Okay? A and B normally are disjoint. Disjoint means they don't have any elements in common. So these two does not have any elements in common. So they are disjoint. I said if A and B are disjoint sets, is it true that A is a subset of B complement and B is a subset of A complement? Justify your answer. I don't even know where the universal set is coming from. Okay, let's take that the universal set is a set of whole numbers. You can solve it and find out if it is true. I. They say that A is a subset of B. Okay, but A cannot be a subset of B. It's not possible for A to be a subset of B if we are using this. You cannot get A from B. It's not possible. So they are not true. Number 17 question, they are not true. Number 18. Number 18 said, list the set of the following. The real numbers. Real numbers are set of numbers found on a number line. 1, 2, 3, dot, dot, dot. Minus 1, minus 2, minus 3, dot, dot, dot. That's for real number. The second one, integers. Integers are the set of negative whole numbers, 0 and positive whole numbers. Dot, 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 minus 3, minus 2, minus 1, 0, 1, 2, 3, dot, dot, dot. You see, this one is in a number line, but this one is not in a number line. That's the difference. Rational numbers. Rational numbers are the set of m over n such that m and n are elements of integers, okay, and n is not equal to 0. This is how we list it. The natural numbers. The natural numbers are the set of only positive whole numbers. 1, 2, 3, 4, dot, dot, dot. Irrational numbers. Rational numbers prime means irrational numbers. I mean, the irrational numbers I know are the surds and the pi. These are the only two irrational numbers I know. So the next one, they say the prime numbers. I don't know how they wrote the prime numbers. The prime numbers are numbers that cannot be divided by anything, but one is not a prime number. So 2, 3, 5, 7, dot, dot, dot. It's continuing. So that is that. So question number 19. Question number 19. Question number 19 said, state whether each of these statements is true. Is pi an element of a rational number? False. I. Is minus 3 an element of a natural number? False. I. Is 3 an element of integers? True. IV. Is the square root of minus 1 an element of irrational numbers? False. This is an element of a complex number because square root of minus 1 is I. V. Is 7 an element of they say that this thing is prime numbers. Yes, it's true. 7 is a prime number. VI. Is minus 5 an element of integers? True. VII. Is the square root of 9 an element of a natural number? True. Square root of 9 is 3 and it's an element of a natural number. VIII. The third root of 2, is it an element of an irrational number? I think yes. True. IX. Is 2 an element of a rational number? Yes. Is true. Then X. Is 2 over 3 an element of integer? False. So we are done with that. Question number 20. Question number 20. Consider the set R real numbers, integers, rational numbers, irrational numbers, and natural numbers. Okay, and prime numbers. And prime numbers. Which of the following are closed under the multiplication, division, I multiplication? Now, for something to be closed, look at the statement of close. For multiplication, it means if A is an element, let me choose for the real number. Let's talk for a real number. If A is an element of a real number and B is equally an element of a real number, for it to be closed under multiplication, it means that if I multiply A and B, that the answer must be an element of a real number. Is it true? Yes, it's true. So, which means real numbers are closed under multiplication. Therefore, real numbers are closed under multiplication. Okay, so II under division, or do I do, okay, let me do multiplication for all of them. So first of all, we've gotten that real number is closed under multiplication, is closed under multiplication. Okay, now Z, integers. If a, let me call it IB, okay, for integers, now if I choose two elements A and B, which are elements of integers, if I multiply them A times B, am I still getting an element of integers? Yes, it's true. So integers are closed under multiplication. Okay, let me just be explaining it. Then the next one, if I pick two elements of rational number, if I multiply them, am I getting a natural number? Yes. So rational numbers are closed under multiplication. If I pick two elements of irrational numbers, for example, root 2 times root 2, if I pick them now, root 2 times root 2 is giving me ordinary 2. So it's not giving me an irrational number. So irrational numbers are not closed under multiplication. Please mind this thing I'm saying. Irrational numbers are not closed under multiplication. Okay? So next one, natural numbers. If I pick two elements of natural number and multiply them, am I getting a natural number? Yes, I'm getting a natural number. Okay, the next one are what? Prime numbers, right? Prime numbers. Yes, prime numbers. If I pick two elements of prime numbers and multiply them, am I still getting a prime number? 3 is a prime number times another 3 that is a prime number, which is 9. Is there a prime number? No. So prime number is not closed under multiplication. Please, oh. So I'm done with multiplication. 20 division. If I pick two elements of a real number and multiply and divide them, if I say that A and B are elements of real number, and the A divided by B, is this still an element of a real number? Yes. So therefore, real numbers are closed under division. Okay? So if I pick two elements of integers and I divide them, am I still going to get an integer? No. Why? Because if I pick 1 is an element of integer, and I pick 2 is an element of integer. If I say 1 divided by 2, is this still an element of integer? No, it's not an element of integer. So therefore, integers are not closed under division. It's better I'll be writing it out one after the other so you will know what to write. So for rational number, the third one, rational numbers are fraction. If I pick any fraction and divide it by another fraction, if I pick A and B are elements of rational numbers, and if I divide A by B, am I still going to get a rational number? Yes. So rational numbers are closed under division. Okay, so the next one is what? Irrational numbers. If I pick two irrational numbers, for example, root 2 divided by root 2 is going to give me 1, and 1 is not an element of what? An irrational number. So irrational numbers are not closed under division. They are not closed under division. So what about the natural numbers? If I pick 1 is a natural number, and I pick 2 is a natural number, and I say 1 divided by 2, is it still a natural number? No, it's not a natural number. So natural numbers are not closed under division. So prime numbers, if I pick 3 as a prime number and divide it by 2, that is a prime number, Is it still a prime number? It's not a prime number. So prime numbers are not closed under division. So the next one, 20 addition. Yes, if I pick any two real numbers and add them, I'm still going to get a real number. So real numbers are closed under addition. I'm now in addition. If I pick any two integers and I add them, am I still going to get an integer? Yes, integers are closed under addition. If I pick any two rational numbers and I add them, am I still going to get a rational number? Yes, rational numbers are closed under addition. If I pick any two natural numbers, and I add them, am I still going to get a natural number? Yes, natural numbers are closed under addition. They are closed under addition. If I pick any two prime numbers, let me say 3 and 7, and I add them, 3 plus 7 will give me 10. Is 10 a prime number? No, it's not a prime number. So prime numbers are not closed under addition. So the last one, IV, subtraction. If I pick any two elements of real numbers and I subtract them, am I still going to get a real number? Yes, real numbers are closed under subtraction. If I pick any two elements of integers and subtract them, am I still going to get an integer? Yes, integers are closed under subtraction. If I pick any two elements of rational number and subtract them, am I still going to get a rational number? Yes, rational numbers are closed under I hope you know that irrational numbers, I forgot to tell you, irrational numbers are still closed under addition, because if you pick root 2 plus root 2, I'm going to get 2 root 2. So irrational numbers are closed under addition. I did not do that, please don't forget. So if I pick any two elements of irrational numbers and I subtract them, am I still going to get an irrational number? Let us check. Root 2 minus root 2 is 0. Is 0 an element of an irrational number? No, it's not an element. So irrational numbers are not closed under subtraction. Once you can get anyone that will disprove it, then we cancel everything. It is not so. So the last one, if I subtract any two prime numbers, am I still going to get a prime number? 3 minus 2 is 1. Is 1 a prime number? No. So prime numbers are not closed under subtraction. Okay? So I am done with this. The next one is number 21, which is the last question for set. Number 21. Number 21 says determine the element of the following. They say that A is equal to a set of x such that x is equal to 2 raised to power n, and n is an element of what? A natural number. So which means that what? A is equal to a set of 2 raised to power 1, 2. Be picking all the natural number you have. 2 raised to power 2, 4. 2 raised to power 3, 8. 2 raised to power 4, 16. Dot dot dot. It continues that way. So for B said a set of x such that x is equal to 3n and n is an element of a natural number. So which means what? B are the 3 times 1, 3 times 2, 6, 3 times 3, 9, 3 times 4, 12, dot dot dot. So C is a set of x such that x is equal to what? 3n, comma, and n is an element of integers, for all, this is for all n less than 3. Okay, any integer that is less than 3, any integer that is less than 3. So let me start from 2. C is equal to, I'm putting dot 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 this side because the minus will keep going, integers. So let me start from 2. Okay, let me start from minus 3. Minus 3 times this is what? Minus 9, minus 6, minus 3 times 3, 9, 3 times 2, 6, 3 times 1, 3, 3 times 0, 0, 3 times 1, 3, 3 times 2, 6, and then that's all, because it must be less than 3. So that is element of C. So thank you very much for watching. In our next video, we enter chapter 2, and chapter 2 says quadratic equation and binomial theorem. God bless you.